Hello, everyone, and welcome to our webinar, 5 Approaches to Remote C++ Development with CLion. So today we have Timur Doumler
Hello.
and Matt Ellis, developer
Hello there.
advocate in JetBrains, and me, Anastasia Kazakova, C++ Tools Product Marketing Manager. So 3 of us today actually gathered here to discuss remote development, a hot topic in these days, I guess. So back in 2019, if I'm not mistaken, we already did a webinar on remote development with Phil Nash, and the recording is available on our YouTube channel. But many things have changed since that, and the world nowadays requires more remote setups. So, and here with me are people who have some experience with the remote work. Matt, Timur, aren't you both working remotely in your current position in JetBrains?
Yeah, I've been working remotely for several years now, and it's going into the office is a bit weird these days.
Yeah, me as well. I'm working remotely here from London. There's no office here, so it's just me.
Okay,
Yeah.
great. How do you feel generally about the remote work? You like it?
I enjoy it. Yeah, I enjoy it. I like it a lot. It works nicely for me. It can tend to get your head down and get a lot of work done. And also you can go and work in a coffee shop, which is always nice.
Great.
Yeah, and my favorite part is that I can work from home, but I can also occasionally travel and see colleagues and other people from the community. So I'm not just stuck at home all year round.
Yeah, that's
Okay.
very important.
Now that travel is coming back, it's kind of opening up again. So that's quite good.
Yeah, that's great, actually. So in the current days, actually, there are many situations when you need a remote setup. So it can be like a weak developer's machine when they work from home, for example, or some maybe security reasons that don't allow storing the source code locally. Or it could be various development environments like containers or similar. And these are super popular to speed up the configuration of the development workplaces, actually. So all these approaches are currently supported in CLion, so you can develop your C++ projects in all of these scenarios with CLion. And this webinar will be dedicated to the ways you can utilize CLion in such scenarios. So during this webinar, you can ask questions in the YouTube questions panel, or if you're following us on Twitch. So the webinar we'll try to answer the questions as they go. So in the panel, in the chat, or with voice in the end of the webinar. The whole session will be recorded and will be available on YouTube. And if you registered in our system for the webinar, you'll get an email with the link, or you can just try and check the YouTube channel for the video right after the webinar. So, and now, Matt, the stage is yours.
That's great, thanks. Let's just move on to the next slide. So thank you very much for that, and thank you all for joining. We're going to be talking about remote development, and CLion covers a lot of different scenarios, and it's got a lot of different ways of working remotely, all of which work in slightly different ways and have different purposes as well. So there's going to be different reasons for using the different ways that you want to look at. So there's 5 kind of ways that we're going to look at today. The first one we're going to look at is remote development with Gateway. Gateway is a new feature across all of the IntelliJ products. So that includes CLion, IntelliJ IDEA, GoLand, WebStorm, and all of these. And this is a way of working completely remotely so that your source and your IDE can live on a remote machine, and then you can connect to it with a thin client. We'll look at that first. Then we'll look at some of the more traditional ways, some of the ways that we've been working with remote development in CLion over past versions as well. So we can have the IDE running locally, but your source is remotely. We're going to look at containers and virtual machines, and we will also look about remote debugging, which is rather nice. And then finally, we'll round things up again with Code With Me, which is another feature across the whole, across the IntelliJ product base, which is all about collaborative editing. So it's a slightly different take on remote development. Okay, so I think then that's it. Timur, is there anything you'd like to add before we dive into some demos?
No, that sounds good. That's kind of the outline of what we're going to be doing.
Great.
And I think you're going to be starting with a demo of the gateway, and then after that, I'll take over and talk about some of the other things.
Yeah, absolutely right. So, okay, we'll switch to my machine, then to my screen, and we'll take a look at Gateway. So, Gateway, as I say, is a feature which is part of all of the IntelliJ products and the IDEs that we've got. And the idea, as I say, is very straightforward. We run the IDE as a service on a remote machine. This service opens up a project which is also running on a remote machine, and you connect to it with a thin client and get a proper useful IDE experience. So there's lots of reasons for wanting to do this. We can have a more powerful remote machine than you've got desktop machine, so you can connect to it with your office desktop, you can connect with your laptop when you're down at the coffee shop, but you've still got then the power of a really good remote machine running there for you. Might be other reasons you want to do it. The company might want to keep your source code and your intellectual property more secure by running that on a remote machine, because then with using Gateway, the source is never downloaded locally to your machine, and it's you don't have to worry about then of leaving your laptop in the coffee shop, which would be a bit of a disaster. So let's dive straight in. Then we're going to run JetBrains Gateway and get started. Now I'm going to run Gateway through the toolbox there. Toolbox, if you haven't come across it, is a great way of managing the install of lots of different versions of your IDEs, lots of different instances. You can have multiple versions side by side if you want to try out the beta versions and so on. But we're going to use Gateway. Now, Gateway is a standalone application, and you can install that. If you're using just a laptop and you don't have any other IDEs installed, you can install Gateway and it will manage everything for you. Or alternatively, if you've got IntelliJ already installed on your local machine, so you've got your desktop machine in the office, if you've got IntelliJ IDEA, WebStorm, and of course CLion installed, then the functionality from Gateway is bundled there as well. So this is all about what's the easiest way to get started. When Gateway runs up here, now we can see we've got a couple of options of how to connect to an IDE remotely. We've got an SSH connection, and this is the one we're going to be looking at today. It's the simplest idea here. You can just give it an SSH connection. Gateway will connect. It'll make sure the IDE is running. It'll load up the project, and it'll connect and get everything going for you. There's no sort of management of that server involved in that, though. So you have to manage the server, make sure it's provisioned correctly, make sure it's got all the dependencies that you want on there, and so on. And so this isn't necessarily useful for working in a team environment where you can roll out a copy of an environment to lots of other people. For that, you can use a system, an orchestration system provided by a product such as JetBrains Space, which is our integrated team environment, and project hosting environment. There you can create and host Git projects and create cloud development environments based on those projects as well. Or you can connect to Gitpod, who are a third party, and they run a similar service to run ephemeral cloud development environments for your projects there. But we'll stick with a simple SSH connection. As long as you've got a license for CLion, you'll be able to use this yourself. You can point it at any kind of server which you want there. You can have it running as a remote machine. You can have it running like I've got here as an EC2 instance. You can have it running as a virtual machine there, sorry. And as long as we can make an SSH connection to it, we can use it. Right now, remote development with Gateway requires a Linux server, but we will be supporting Windows and Mac in the future. So the first thing we need to do is set up a connection via SSH. We can create a new connection. We can manage them. If you've used SSH connections in CLion before, then you're going to be familiar with this interface here. We can add a new item, give it a host, give it a username, give it a password or a key pair, or tell it to connect with OpenSSH. And once we've got a connection there, we just simply select it here and click Next there. What Gateway is going to do right now is going to connect to my remote machine. I'm using an AWS EC2 instance. It's going to connect via SSH, see what versions of the IDE I've already got installed, and then offer to install them if I need, or update them if I need to. So you can see here from the drop downs, I can use IntelliJ IDEA, Golang, PHP Storm, and so on, and of course CLion. It shows you the version here. I've got 2022.2 already installed, and I'll select that. We're going to use that. If it wasn't installed, I could select it, and of course Gateway will install it for me and get going. The next thing I want to do is select a project directory. What is the project that CLion is going to open for me? And we can click the 3 dots at the end there, and it will show us a file listing here of the remote host. It shows me what's going on there. And I've got a project already checked out here, just a simple calendar project, and I'm good to go. If I didn't have it clicked there, I can just very quickly open and put an SSH terminal, and I can do git clone or whatever, and get a project and get working. Now, when I click next, Gateway is going to do several things. It's going to make sure that, as I say, this IDE is installed on my remote machine. It's going to start it and open the project, and then it's going to run the thin client. Now, the thin client is how you actually interact with this IDE running in the remote machine. What we've done here is essentially taken CLion, taken all the whole IDE range, and split it in half. We're running a back-end service running on the remote machine itself to provide all the language processing, and this is going to index your files, it's going to do all the work, it's going to do the navigation, the building, the debugging, all of that kind of work. And then we've got a thin client as well, which is a very stripped down version of the IntelliJ platform, and so it actually gives you a very familiar user interface, something that you're already used to.
So Matt, you
yes.
don't actually have CLion installed on this machine at all, right?
I do have CLion installed on this machine, but I don't need it. So if I go to Toolbox here, we can see that CLion is in there somewhere. There it is. CLion's there already, but this is not using that install there. So I do not need any IDE installed on my laptop right now. I just use Gateway and the thin client, the JetBrains client, to connect to CLion, which is now installed and running on my remote machine.
That's really cool. Thanks.
That's really cool, and it's the thin client here, the JetBrains client is, as I say, it's based on IntelliJ and on the IntelliJ platform. It's based on the same code that CLion itself uses, and so it looks like CLion. I've got my notifications window, I've got my project window, and I can open this. Oh, no, missed. I can click on those and open those. I can open my files, and I can open some files, and those will open up there, and it gives me syntax highlighting and everything. I've got a terminal down here as well, so when I'm connected to my terminal, I'm actually on my EC2 instance there, and I can see I've got all my usual sort of command line tools that I can be using. Git status. I don't need to use git status though, because I've got my Git tool window down here from the remote machine. So there's all the sort of functionality that you'd expect from CLion is flowing through into the JetBrains client, but all of this information is still living on the remote machine. So for example, here, these files now, I'm seeing them here with syntax highlighting, but all of that is coming from the remote machine. I don't have these files locally on my machine. They're not copied down. They're just used for the editor itself. But because this is based on the IntelliJ platform, it's based on CLion, it's got the CLion editor. So all of my editing functionality is happening locally. And so I get the sort of responsiveness of working with local editors there. So if I do my code completion there, I can see I've got all my completion for the various fields and methods and functions and whatnot that we've got going on there. And of course, I can do all the usual sort of features that CLion you'd expect from CLion. I can control click and navigate around. I can open up my header files and I can use that control click to navigate to those. I can navigate through to the system headers as well. And again, all of these are files that are being hosted on the remote machine. It's not looking at any files I've got locally. And once I'm on a file there, I can do Alt-Enter. But actually, no, I can just do things like navigation there, and so do find usages. Where's my find usages? Let me just see. My shortcut's gone. Find usages. Yeah, no, okay, doesn't want to do find usages on that. Let me just refresh my project folder a sec. Let's see, is that going to give me that? No, unfortunately, I'm not going to get find usages, but I can do things like navigate between the header and the header and the declaration and the definition. And I've got things like my normal navigation item from the gutter icons there, so I can see when things are being derived and overridden. And so I can navigate around and see all those kind of things. I should be able to do find usages, but it doesn't want to do that. But I can do sort of a whole lot of navigation going on there as well.
You get a project structure as well, right? And basically everything that CLion does.
Absolutely. I can do my shift, and search for items there. So if I pull this down a bit, and if I just search for Gregorian calendar, we can see now that it's finding all of the usual sort of features that I'd expect there. Oops, I want to change that. I can search and do shift and find my calendar. And I can navigate around in the way that you normally expect, which is great. I can do other interesting things as well. Let's go back to my Gregorian calendar there, I think it is. And in fact, let's see. Let's just put a breakpoint here, and let me see if I can just start debugging this here. Well, in fact, before we, so I can now do debugging as well. You've got the normal sort of set of run configurations that you'd know and expect based on your CMake file there. I can select whichever run configuration that I want, and I can set my targets and so on. I can edit them as well, so I can bring up the dialog to make changes and add program arguments, change the working directory, and so on. And I can then run the application as well, and it shows me the console output. Now, one of the important things about working with remote development is that it's applicable it works better for certain types of applications. So if you've got a graphical user interface, then it's a bit tricky because it's hard to display that graphical user interface remotely. So if you're working on like an X11 project, that might work. However, if you're working on other things, it can be harder to get the user interface to be displayed properly. So it works best for things like console applications or for server applications as well. And when you run a server application, Gateway will recognize when you're opening ports, and it will automatically forward those ports for you as well. Now I've got a simple console application here. And so if I run these through, wait a minute, let me see, I've put a breakpoint in the wrong place. I can do things like finding file as well. And we can see that there's the outputs there. Now, is that going to find the file? That doesn't want to open that file. Okay, so that's a bit tricky, so we'll come back to that. So instead of looking at that, what I'm going to show you instead is other features that you might be familiar with from CLion, things like, oh, where's that? Is running tests. And this should pick up the tests any second once CLion has caught up. Is it going to give me the tests and the fixtures? And we normally get the gutter icons, but it doesn't want to show those today either. So I'm having a few gremlins with my tests, unfortunately. But we normally get the gutter icons here next to the test, and we should be able to run those and put the breakpoint in there and hit the debugger with those as well. That's a sort of very quick overview of what Gateway can do for you there. It can give you a very rich user interface on top of a remote version of CLion running completely remotely on a different machine here. And I've got an IDE which looks and feels just like CLion running locally. And of course, it's because it is CLion running, well, because it's a version of CLion running completely locally, I can customize it as well. So I can change the theme here. I can change key maps. I can install a plugin like IdeaVim to give me a different experience in the editor. And I get all the nice features such as the structure window, showing me lots of things there. I can navigate around the place. I can show the member search item here and type in there to very quickly find items and navigate around. I've got my run configurations. I can run, I can debug, I can build, I can do CMake. I've got my terminal. I've got my version control. I've got a great experience there. And again, just to sort of reiterate, if you have CLion already, you can use this. You've got the functionality built in, and you can connect to a remote machine running SSH and try it out for yourself. And so I think I'll leave it at that for now. Timur, are you going to pick up the next item, is it? We can take a look at a different way of working with remote development.
So this is kind of Gateway where, as Matt said, basically everything runs on a remote machine. You have CLion running on a remote machine, all the IDE features, the code, and you just have a thin client locally. Can we go back to the slides, please, and go to the next slide? Yes. So now we're going to talk about remote development with local sources. This is kind of the second thing we're going to talk about. And that's kind of a thing that has been in CLion for a bit longer than Gateway. I think Nastya said since 2019. And the difference here is that you actually have the sources locally and you're running CLion locally. But then you're compiling it on the remote machine and you're running and debugging on the remote machine. And CLion kind of synchronizes your local client and the code on your local machine with the kind of remote version. And so it's going to like keep them in sync typically via, for example, SSH via rsync or something like that. Now, why would you want to do that? If you could go to the next slide, please. There are a few cases where even though Gateway is absolutely great, like you might want to opt for the local sources approach instead. One use case is if you can't run CLion on the remote machine, or if you don't want to. For example, you're running some kind of exotic or old operating system that CLion doesn't support, or maybe your remote machine is just not that powerful. You don't want to run all the heavy IDE features like indexing and code completion like on the remote machine. Another use case is you want to quickly switch between running locally or remotely. For example, you're developing something, and most of the time you're running it locally, and then every once in a while you want to run it on the remote machine. And in that case, it's just as easy as switching a run configuration, and we're going to see that later. Or if you have like multiple hosts going on and you want to wait very, very quickly, kind of switch between them. And then the other case is if you're for some reason your network latency is just too poor for Gateway to offer you a great experience. So then you're going to again run kind of all the IDE features locally, and then only when you kind of compile and run, you're going to synchronize with the remote host. So let's see how this works in practice. Let me just share my screen. I have a project here which is relatively boring. Some kind of struct that prints info about the compiler, the host name, and what operating system I'm running on. And then I'm kind of filling that information. And there's a bunch of if-defs here to make sure it works on Windows, Mac OS, and Linux. So there's some boring kind of code calling some system functions there. And then there's like a main, which is kind of just printing that info. And if I run this on this machine here, which is a Windows machine that I'm doing this presentation from, it tells me that the compiler is Microsoft compiler, which is what I have configured here. Omadon is the name of my machine, and I'm running some Windows version. Never quite understand how Windows version numbers work, but that's a different topic. And so now I have a remote machine here. So it's actually not a virtual machine. It's actually physically another machine. It's here. I'm running Ubuntu here. And I want to run this project on this remote machine that I have sitting on my desk here. And it could obviously be anywhere else in the world. It just happens to be sitting on my desk. And if I can kind of zoom in here, I can show you that. I don't know if you can see that. It's called Parallels is the username here, and the IP address is 192.168.0.77. So I'm just going to SSH into this. And again, it's not necessarily a machine on my desk. This is what it is right now, but it could be a machine anywhere in the world, like server somewhere. So what I'm going to do is I'm going to create an SSH configuration, which is something that we already seen on Matt's computer. You can find this under Tools, SSH configurations. I'm just going to add a new one, enter the correct IP address here, which is 77. Parallels is the username. Type in my password here. I can test connection. So that works. That's great. So one thing I can do here is actually I can start an SSH session and get a terminal just from within CLion. This is a very, very useful feature. So I can just do start SSH session, select like the credentials I've just entered, and now I have a terminal where I'm SSH'd into that Linux machine that I have here next to me. So I can, for example, check what kind of compiler we have here. We see that we have Ubuntu and GCC 9.4.0 going on here. So now I just want to basically run this project on this remote machine. So the way to do this in CLion is to go to the settings and create a new toolchain. So if you go to build execution deployment toolchains, this is just the default here, the Microsoft Visual Studio toolchain, and I can just add a new one and select remote host. I'm going to give it a name. Let's call it remote Ubuntu. And then I just select the SSH configuration that I have created previously. And now CLion should automatically kind of SSH into it and find C compiler and C++ compiler and CMake and everything. And then the other thing I can do here to make this easy to work with, I can create a CMake profile. So this is just the default CMake profile. I can make a copy, call it debug remote Ubuntu, and then just select the toolchain I just created here and click OK. And now CLion is saying loading CMake project. What it's actually doing is it's running CMake on the remote machine now. So it's like loading the CMake project on the remote machine now, and then it's going to give me the result. There we go. I get an error message, apparently. So I'm running an older version of CMake on the remote machine. So let me just quickly fix that. So again, I'm doing this locally, and then when I do reload changes or I change anything, it's synced automatically via rsync or something like that via SSH to the remote machine. And now it's running on the remote machine. This should now succeed. My network is not particularly fast, so it might take a little while. And you see it tells you that it's synced some files here. So this is the difference to Gateway. It's actually physically transferring some files over the network to keep the project in sync. So it has a copy locally and it has a copy on the remote machine. OK, so that all worked. So now we have the debug remote configuration here, so we can run this. And now it's giving me Pegasus, which is the name of the remote machine. It's giving me GCC 9.4.0, which is the compiler that's running there, that it has it compiled it with, and it tells me that we're running Ubuntu. All right, so that's great. I can do more stuff. I can, for example, print. I can put like a breakpoint somewhere. I don't know. For example, here. So now I'm debugging on the remote machine. I can step in, and now I'm in the std_string header, which is, again, on the remote machine. It's just like if you scroll up, this is like a GNU C++ library header. So it's not Windows. It's not a file that exists on my machine. I can inspect the variables there. Wait, let me do this again. Right, so for example here, UTS name, that's just a Linux struct that holds like system information. And again, I can navigate to the definition of that, for example, with Control-click. And now I'm in some kind of Linux system header. So I have the full experience of navigating, debugging, running. The code is being compiled on my remote machine, but I can do everything locally. So what else we can do? We can actually configure how the synchronization is happening. So I can go to settings again and then to deployment. So I've created a deployment. So this was automatically created for me here. And if you go to mappings, we can see this is the path where the project is being copied to on the remote machine. So if we have our SSH terminal here, and we just go to that folder, we can see that here we have the whole project. checked out. So CLion just copied it there. I can print the main file, and so this is the remote. But then, for example, if I edit the code, let me just make some kind of edit here. And then I run it again, and I'm doing this locally, right? But if I run, then it's going to be synchronized with the remote machine. And if I then go back to the SSH session and just look at that again, you see that the code has changed on the remote. So CLion is keeping everything in sync for you. Another thing I should say is that officially, currently, we only support Linux as the remote, but your local machine can be anything, Mac OS, Windows, Linux, whatever you're running CLion on. So this is remote development on with local sources. Not sure if we should maybe we have a few questions perhaps, or should I just keep going?
I think we can keep going. So
All right.
there were some questions on the thin clients. I think we'll cover them in the end.
Yeah.
So we'll be back to
Okay.
them. So let's just keep the flow.
So what I just showed basically works with any remote machine that you can SSH into. And it's actually the SSH configuration that I created was actually the same kind of SSH configuration that Matt created for the gateway thing, but the principle is different, right? For gateway, as we said, you just run a thin client, and here you have CLion installed, you have the sources locally, and it's being synced with the remote client. But it works with anything that you can SSH into. So it could be a machine on my desk. It could be somewhere, a server somewhere, but it could also be a virtual machine, for example, any kind of virtual machine. As long as you SSH into it, this is one way you can work with that. However, for certain setups, we actually have easier and better ways of working, which are customized to that particular scenario. And so in particular, different kinds of containers and virtual machines that CLion knows about and where it can do something a bit more clever and a bit more streamlined. And in particular, I want to talk about WSL2 and Docker. So WSL2, I'm not going to explain too much about what this is, but basically, I'm sure many of you are familiar with it. It's basically a Linux kernel running on some kind of virtual machine, but it's not like VirtualBox or Parallels or something like that. It's actually a VirtualBox that's very tightly integrated with Windows. So things like file sharing, networking, etc. is seamless. It just completely integrates with Windows, and it allows you to run a Linux distribution of your choice on top of this Linux kernel that's kind of integrated in Windows. And then this way, it allows you to actually run any Linux software basically on Windows through this, on top of this distribution that you have. I'm not going to show how to set this up because there's a lot of documentation about this on the internet. However, I do have it running here already, so I can just open a Ubuntu command line prompt here. So this is my WSL2 running with Ubuntu on top of it. So I also have a C++ compiler here, in this case GCC 930. Now I can run my app, which is printing the kind of version number, hostname, etc., from basically within this virtual machine, within this WSL2 distribution here. And of course, I could set it up via SSH like I did, but actually it's a lot simpler. If you have WSL running, you can just go to the toolchain settings again, and there's a custom toolchain for WSL. And if I just create one of those, it just automatically recognizes all the WSL Linux distributions that I've installed. In this case, it's just Ubuntu. So I can just select that, and that's it. And it's just going to immediately recognize that I have a compiler there and a toolchain. So I can just click OK. I can create a CMake profile for it as well. Let me just call this WSL, and I'm going to select the toolchain again. So now it's reloading the CMake project, but this time it's running it in WSL. And I can now run this. Hang on, I think I need to wait a little while before it finishes. Okay, there we go. So I can select this now and run this within WSL. And here you see now I get the host name is Omidon, which is my Windows machine, and not the remote machine. But yeah, it tells me GCC 930, which is the compiler I have in WSL, and it's telling me that it's running on Linux. So how does this work under the hood? Maybe this is interesting for some users. The there is actually in Windows, you can obviously open the console, but there's also this WSL command. So you can basically run anything in WSL. If you just something like, WSL -- distribution and -name Ubuntu. And then I can just run any command, like, for example, I can say GCC version again, and it's going to run that. So what CLion is actually kind of doing under the hood is actually running all the kind of compiler commands and everything it needs to do through this utility. And the nice thing is that WSL2 has full access to the Windows file system and vice versa. So unlike the previous scenario, CLion doesn't have to upload anything anywhere. It doesn't have to download anything from anywhere. There's no copying going on. You just have immediate access to the file system from within WSL. So you can just run the project there. So that's going to be a lot more efficient. And CLion can also look into the WSL file system to get all the header search paths and everything it needs. So yes, so we support this. There is also a bunch of other scenarios on Windows like Cygwin and MinGW, which I'm not going to talk about. But I do have another video actually called Windows Toolchains in CLion, where I go over this in a lot more depth. So you can check this out if you're interested in that. One more thing that I want to show now, though, is Docker, because it's kind of also similar to running a virtual machine. It's running basically running a container. So if you're not familiar with Docker, you can run your code in a container, which is again going to have some kind of operating system going on there, like, for example, a Linux distribution. But it's kind of containerized in this really, really useful way. And Docker is a very, very good way if you need a very particular reproducible development environment with a very specific developer setup, and you want to be able to just summon these containers very, very quickly and efficiently. And so how to set this up, again, I'm not going to go over this here. Docker has extensive and very good documentation online, but I do have it running here. So I do have some containers here. So on macOS and Windows, you have this Docker for Desktop tool. On Linux, I think it's all purely command line based, but it's pretty much the same thing. I can go back to the console here to show that it's running. Docker info. Right. Oops. Sorry, I think how do I? Hey, I think I moved the title bar out of my screen. How do I get it back? How do I move it? Ha, that's funny.
Is that Windows? You can use Alt space and M.
Alt space.
And the arrow keys even.
And then I can do. Sorry. This is weird. There we go. Okay, this is what I wanted. So what we can do is we can, if you want to do some C++ development, we can set up a Docker image for that purpose. So I actually have something prepared here. We have a test Docker image here. I've written a Docker file. I can just show you what's in there. So we are just basically taking Alpine Linux, which is a very, very, very lightweight distribution, which is kind of very good for this kind of container stuff. It's just a few megabytes, just kind of very bare bones, minimal Linux distribution. And then I'm just installing kind of a C++ toolchain, compiler, CMake, and everything we need. And it's just kind of scripted in this way that we just have this Docker file. And then we can build an image, build a Docker image, Docker build minus, and then we can give it a name. I'm going to just call it CLion test image. And then that's actually really quick. We're already done. And if you type Docker images, here it is, CLion test image. So that's all configured in Docker now. And CLion actually just can hook into this, and it's all very seamless. We can go to our already familiar toolchains settings here and select the Docker toolchain. And it already knows about all the images that we have installed here and configured. So we just need to select our image, basically. Another thing that we might want to look at is how you want to connect to Docker. The safe bet is usually just the first option, the default, which on Windows and Mac is Docker for Windows and Docker for Mac. So just leave that setting there. It should, again, detect automatically the kind of toolchain and compiler that exists on that image. and then again, we can create a CMake profile. I'm going to call this debug Docker and just select the toolchain again. You see, it's kind of very similar to what we did before. And now it should load our CMake project on inside the Docker container. So, all right, I'm getting another error here. So I think, yes, so in the Docker container, we're running some quite old version of CMake. So I'm just going to have to quickly downgrade this here. 9. Let's see what happens now. All right, so the Alpine Linux doesn't even know about C++20 yet. So we need to actually use C++17 here. And now it should work. And obviously, we can just install a newer compiler as well in the container. All right, so CMake is now running CMake inside Docker to configure the project. And now I can just run it. Oh, hang on, that's still WSL. So I can now easily, very, very easily switch just with one move of the mouse between like the different remote hosts here. So I can just select Docker and run it. This is what I was saying earlier, that it's very good for switching between different remote hosts very quickly. All right, and now we're running on Docker. So here we have this like somewhat older GCC compiler 640, and the host name is the container ID of Docker. So that's this kind of weird string. And yeah, we're running Linux. No surprises there. Maybe it's interesting also to say a little bit how this runs under the hood. Again, there is no downloading, uploading, or anything like this going on. So with Docker, actually, it's very efficient. CLion can just take the project folder and just mount it into the Docker containers file system. Docker container has a virtual kind of sandboxed file system. And CLion just goes ahead and mounts the project folder into there. So that's going to be quite efficient. There's a few settings here that you might want to do if you're on Windows. You might want to make sure that you use a WSL backend here, because that's going to make it more efficient. And you might want to kind of select the distro that you have here. And there's like a few other things that you can do to set this up. I do have another video which is just about that. It's called Docker integration in CLion. I'm also showing the Docker plugin there that we have and lots of other stuff. So if you want to know more about Docker setup, please watch that video. One more thing that I want to say here is that this currently only works if your Docker instance is running locally. So if you have Docker running somewhere on a remote machine, then this very easy integration wouldn't quite work, and you would have to do the kind of SSH thing again that I have shown earlier. All right, so we're done with kind of remote with local sources. We have seen containers, virtual machines. Now we're going to go and deal with a physical machine again, but a very different kind of physical machine. I actually have a little setup here with a Raspberry Pi. If you can have the PiCam, please. Yes, so this is sitting literally here right next to me on my desk as well. I have a little Raspberry Pi 4 Model B here, which was, by the way, very hard to get. Currently, it's not easy to find one of those. And what's going on here is that I have this little Raspberry Pi here. It has these like general purpose input-output pins here, and then I connected it with some jumper wires to a breadboard. And I have LED. Maybe you can see it. It's quite faint at the moment because random like voltage coming in. It's kind of glowing quite faint. And then a resistor to make sure that the LED gets the right amount of current and doesn't blow up, which wouldn't be very nice. And what we're going to do today is the hello world of embedded development, which is make this LED blink. So this is the famous kind of blinky demo. Oh, I think, is the PiCam still online?
PiCam still looks like it's there. Yes, it's still there.
Okay, so okay,
we do love a bit of PiCam.
So we're going to make this LED blink, and we're going to see what happens on the PiCam. And now I actually have the Raspberry Pi desktop here in VNC. So this is the Raspberry Pi desktop. So I have set up SSH here somewhere. I don't remember where that was. I think it was here, Raspberry Pi configuration. So yeah, I've said that I've enabled SSH here in VNC. So this is VNC, so I can just look at it from my Windows machine. I don't have to have a monitor connected to the Raspberry Pi. And just let me see what IP address it has. Okay, so it's 075. So I can again SSH into it. Let me just create an SSH configuration for that. So that would be in Tools, SSH configurations. What was it? 075, right? His name is Timur. Was that right? Yeah. So Timur host name is Raspberry Pi. Let me just put the password here. All right. Connection works. So now we have SSH'd into our little Raspberry Pi from CLion. We can again run an SSH session. Here we go. There is also a compiler here, and we have CMake here as well. So we're running here, slightly newer GCC 10.2.0, and we have CMake here. So how to set up Raspberry Pi for C++ development is actually an interesting topic, and I'm planning to do a video just about that, like how to do like the setup for the Raspberry Pi starting from scratch. So I'm not going to go through all of this now, but I'm going to do. I'm planning to do an extra video just about that. So for all of you who want to learn how to develop C++ on a Raspberry Pi, there's going to be a video about that. So one thing I want to say is that the Raspberry Pi actually it's an embedded Linux, but it is a Linux, right? So as you can see here, we even have a desktop and everything. So we could theoretically run, do what we did before with the SSH, where we compile everything on the Raspberry Pi, or we could even run Gateway on the Pi, right? It's a Linux, so CLion will run on it. But we don't really want to do either of those things because it's quite a tiny little machine. It's probably going to be a bit slow to run Gateway, or even just to run the compiler, to compile your project on a Raspberry Pi. If it's a big project, you probably don't want to do that. It's probably going to be quite slow. So what you want to do is you want to do something else. You want to actually compile the code on our local machine using a cross compiler. And only then when we have the executable, we just want to take that executable and just upload that to the Pi and just debug the executable there. But we want to do this remotely, right? So we want to control the Pi from our local machine. So for this, there is a custom toolchain which you can download with a cross compiler, because Raspberry Pi is an ARM chip, right? So you need a cross compiler to do that. So I already have done this here. Again, how to set this up from scratch. I'm going to do another video about that because there's quite a lot of stuff going on here. But I do have this cross compiler installed. So what we need to do here is, again, we have a toolchain for that. It's called the system toolchain. And what it's for, it's basically to select your own custom compiler. And that's very, very useful for any kind of embedded scenario, whether it's embedded Linux like here or bare metal. And what we need to do is we need to just manually select our custom compiler here. So here I need to do that. So you see here, it's this kind of Raspberry Pi toolchain that I have kind of just installed earlier. So I need to select the, what is it, gcc.exe and g++.exe. There we go. And then also create a CMake profile again. Debug, I'm going to call, hang on. Let me rename this toolchain. Let's call it Pi. And this I'm going to call debug Pi. This is our CMake profile. I'm going to again select the toolchain here. All right, and now I can compile. Oh, actually, I forgot I have another project actually to do this. So let me close this and open the PyBlinky project. So the PyBlinky project has it has the same print info, so stuff here going on. So if I click in there, this is exactly what we saw before. But then it also does this blink. And so how do we actually blink the LED on the Raspberry Pi? So we need to control this GPIO pins. There's different ways to do this. Again, there's going to be another video about that. But let's just say for now that there is some way of doing this, which is kind of all the stuff up here. And then we have this infinite loop going on here where you flip the value of the LED from on to off. And then we just, put the thread to sleep for some time. And that's going to determine the frequency of our blinking. So it's kind of a very crude way of doing it, but it works. So let's see. It's another project. So I actually need to do all of this. I don't need to do all of this again, but I do need to create the CMake profile again. So the CMake profile is per project. But I can just select the toolchain here that we created earlier. And this should now work. However, if I try and run this, now I get this error here. It's saying it's not a valid Windows 32 application, which is not surprising because we just compiled an ARM binary with this cross compiler, and we're trying to run it on our Windows machine. So that's not going to work. So what we need to do is we need to actually run the compiler, compile the binary locally that we just did, but then run it remotely on the Raspberry Pi, right? So that's what we want to do here. So again, the difference from before is that we're not compiling remotely, we're compiling locally, and we just want to upload the binary to the remote machine and then debug there. For this, we can use a feature which is called remote debugging. And the way to do this is to add a run debug configuration for this. So there's all types of run debug configurations, and two that are particularly interesting in this context are called, where are they? Here we go. Remote debug and remote GDB server. It sounds like they're kind of the same. There's a subtle difference between them. So remote GDB server is basically if you want CLion to automatically handle all this, to automatically compile the executable, upload the binary to the remote machine and the symbol file, automatically start the executable, attach it to GDB server, and just kind of do all of that for you automatically. And it only works if your project is a CMake project and if you're using GDB and GDB server as your debugger. And remote debug, that's the other option. It's slightly different. It's where you want to kind of do this manually, right? You have your own executable, you know where it is, and you want to kind of manually configure where the executable is, and manually attach it to the debugger. And there, you don't need to have CMake or any particular project model, and you also don't need to use GDB. You can also use LLDB. But for the purposes of the demo, we're going to use GDB Server because we just want CLion to kind of handle everything for us. So we're going to select that. We can call this, I don't know, GDB Pi. And we need to select our CMake target here, which is just this PyBlinky, and then the executable as well, which is just the one produced by that target. CLion comes with a bundle of GDBs, which is multi-arch, so it supports ARM and Intel and everything, so we can just use that. We need to select our SSH configuration. This is going to be this one. We just created that earlier. Here, again, we can configure where the executable is going to be uploaded to on the Raspberry Pi. So yeah, we're all done here. We can click OK. And now, if we, so now you also see that actually the run button has disappeared, right? Because what we're doing is we're going to run this remotely on the Raspberry Pi and then attach a debugger to it. So the only thing we can do with it is debugging. So you still get the debugging button, but not the run button. And so that's going to now do the remote debugging. So if you just hit that, it's going to compile locally and then upload the executable, attach the remote debugger, and now you can see that the LED is blinking. So that's now running on the remote machine, which in this case is the Raspberry Pi. I can put I don't know, I can put a breakpoint here, and you see that the blinking stops. I get obviously all the usual debugging features here. If I just step over this and let the loop go around one more time, the LED goes on again, goes off again. I can also kind of mute the breakpoint. Oops, no. Sorry, that was the wrong button. I can mute the breakpoints and let it run again, and then it's going to be blinking again. So that's remote debugging. I think that's really cool. But that's not everything. So I got this working now locally on my machine, but what if Matt now wants to join the party and actually join my debugging session here and do something with that Raspberry Pi? How would I do that, Matt?
Yeah, so that's really cool. I mean, I love those demos. The one thing I really like about the demos there is everything's based on toolchains, and it's the same sort of process again and again to talk to different machines there, and it's nice and easy with a drop down to select the target you're going to work for. But yeah, let's do something a bit more interesting. Let's have a look at Code with Me, which is the collaborative editing feature for JetBrains IDEs such as CLion there. Now, if you look at your toolbar now, up at the top there next to the build button, you've got a little icon which looks like two people. If you click that, that's Code with Me, yes. So if you click that there, we've got an option here to enable access and copy an installation link. This is going to start up a collaborative session which I can join and help you edit your code. Now, the first thing you get hit with here now is a dialog which is going to give you some permissions. And you can work with this in a different way, a number of different ways. So, for example, if you wanted to do a code review, for example, or a teaching session, let's say it's a teaching session, you might want to be read-only, invite people in so that they can look at your code, but they can't make any changes there. So you can teach people how to do things, but you're safe in the knowledge that they're not going to be able to change anything. You can also give them permissions to edit files. And thereby then you can sort of work collaboratively together. I could be writing something and you could write the tests and so on. We've also got full access and custom there as well. If you just click custom for me a second and then expand the permission details at the bottom, we can see now all the sort of different options we've got there. We've got edit any files. There's a link there as well if you wanted to hide a file. So for example, if you had a config file which had got passwords and things in, or which set up security rules, then you could hide that and make sure people couldn't modify those. But you've also got some options there with the terminal, run and debug, and various other tool windows as well. So we'll leave the tool window, the terminal window as view only, so I don't go in there and try and delete all of your files. But we'll change the run debug to was it full access. One thing to note about the terminal is that it is a way of exposing your files to somebody else. They can do anything on your computer there. But if I try and edit something on Timur's machine, he will see exactly what I'm doing. So that there's trust required there, but also you get to see what's going on. Finally, before you click OK there, the last thing on the item there is we can automatically start a voice call there as well. So all right, if you click enable access, Code with Me will now set up a session. It'll copy a link to the clipboard. We've got a little notification there to say that that's done. If you can send me that link through the wonders of private chat.
Let's see, Control V.
Yeah, just paste it in there. If I grab a copy of that, and if I just start this link now, and then I join the session. So I click the link and join the session. That's now going to start up an instance of the JetBrains client that we've just been using now to work with remote development. We've got the same client, which is just downloading now for Code with Me. And
so that's the thin client again, right? That we were using for
Gateway. It's a thin client. It's exactly the same client. And here it comes. I'm on the wrong screen. One moment. And you should now actually see, in fact, actually, you can see my screen there. Yeah, it's actually migrating information there. So one thing about the thin client, do you see a security code on your machine?
Yes,
6397?
Yes.
Right.
So I have a security code, and I'm being asked to accept. So let me just
let me in. That security code means that
accept.
we've got an end-to-end encryption going on
right.
there. There was also a little bit of a progress bar as we started there to say that it's actually copied my settings from a previous install there.
Do you want to switch back to your screen?
And so hello.
Yeah. I just wanted to ask if you want to switch back to your screen.
Okay. So I'm on my screen there. So this is my screen. We're still on here. We've got the thin clients, same as before. It looks very much like what we had before, with the what I'm trying to say, with the remote development system here. I've got all the same sort of things we had before. The projects. I can open files. I can look at my .h and my info.h and everything. I can control click. No, I don't want that. Do you want to end the debug session that you're in there for a second, please?
Okay. Now there you go. Our LED has stopped blinking, as you can see.
Yeah, that's cool.
It's now just on.
We'll take a look at that again in a sec. But I can do things like, I can navigate around. I can see what's going on. If I jump to my compiler.info, I can do find usages on the info, and I get to see all the results as you'd expect there, and sort of navigate around and work with those. I could run a refactoring there and rename it if I wanted to. So rename it to a different structure. I should be able to rename the thing there to be different value there, and it's updating it. And I'm working with Timur's code here, so I'm working on my machine. Again, I haven't got a copy of the project. I'm just working remotely against Timur's project and application there. So it's kind of like how remote development works in a way. So remote development puts an IDE and the project on a remote machine, and you connect with the JetBrains client, and all of the work is happening on the remote machine. From my point of view right now, Timur's machine and Timur's CLion is doing exactly the same thing. I've got a remote machine running, and Timur's IDE is providing all the information there. But the really interesting thing is we're doing collaborative editing. So we're both in the same file at the same time. So we can both start typing. Are you in info.h? We can, so I can start typing here, hello from Matt. And at the same time, we've got hello from Timur down there as well. And so we can both be working on the file at the same time. If I hover over the cursor, I can see where Timur's working, and we can work collaboratively.
Yeah, I see your cursor also on my screen, and I see like what file you're on. I have a little M here, which means that's the kind of file you're looking at. This is your cursor here. Yeah. So I can. Really nice. Do you want to talk about like the following modes and things like that?
Yeah, absolutely. So it's really nice. In the tab of the editor there, as Timur points out, we've got this little icon there to say who's in which file there, which is nice. So I can see where it is. So I could be in main.cpp, but I can see that Timur's in info.h. And if I drop down the same icon in the toolbar with the people there, the code with me icon, then we've got different options there. I can go to the to Timur. I can just jump to exactly where he is. So if I've been working in something and I want to go to see where Timur is, I can just use that jump option to go straight there. I can also do the follow as well. So if I'm now in follow mode, you can see that my screen has got a little frame there which says I'm following Timur.
So I'm just going to scroll around.
Yeah, if you scroll around, if you go to different files, then I've got my hands, see I'm not touching anything, and my screen's moving around for me. I get to follow and see where Timur is. So this is great for the scenario of mentoring and code reviews, where I get to show where everything is. I get to talk about some code, to navigate around and explain what's going on there. And if you even go to the project file, project structure there, I'll follow you to the project structure and then into the other tool windows as well. And we worked both ways too. So I could actually then say, well, I can say, well, stop following now. So I don't want to follow that. But I can say, we're going into full sync mode. And now we both sort of, Timur gets to follow me and he gets to see where I'm going. And so we can both work together. So it's like, I've just got an idea. So if we jump around and we can move around and see things and navigate around and get to see what the other person is seeing. So it's a great way of working sort of collaboratively. And it's not just about the code as well. So let me just stop the sync mode there. if I go back down, if I go down to the bottom right here, I've got a tool window, and we've got a video call as well. So Code with Me comes with video calls. We wanted to chat with it. If we weren't doing, a webinar where we could talk to each other, then we could do a chat, and that's it. If we turn on the cameras and everything, and there we go. We can see. You've got far too many cameras going on there. But we can do voice chat, and we've got text chat as well. So it's like, I don't know, check out the bugs in this. You can send each other links. You can code snippets and all sorts of things like that there as well. So it's really useful. The other thing you can do, if I just expand this out just a little bit further, where are we? There is we've got another tab here for port forwarding. This is really useful if the project you're working on together is some kind of server project, because then we can forward ports from Timur's machine to mine, and I can connect via web browser or whatever, and actually interact with the service that we're building, which is really cool. But that's not the fun bit here. Let's just go back to here. I'll put a breakpoint in, and let's start debugging.
So you're now starting the debugging session, right? I'm not doing
I'm starting
anything.
the debugging session. Yeah. And we are now in the debugger. Let me just flip over to that.
The LED just turned off, so definitely did something.
Yeah, and so we're in the LED, and if we go into frequency, you can see that I'm just in the debugger as normal. I can sort of step up and down the call stack as you would expect. I'm in the blink method here. I got my LED control object here. I can see that is on is set to false, and if I can change the frequency here, I could do set value. Let's just change it to 100, and then if I take the breakpoint away and start running, then we can see
now it's blinking a lot faster. Yeah,
it's blinking a lot faster, and that's really cool. So here there's some remote development for you. I've managed to change the frequency of an LED blinking on Timur's desk through the powers of Code with Me and remote development. So we were kind of hopping between lots of different things there, but it shows you the kinds of very interesting scenarios you can do with remote development. You can do pair programming, or you could do remote development where everything is on a different machine, where you want to debug on a different machine, where you want to run on a different machine, compile on a different machine as well. So you've got a lot of flexibility and a lot of use there as well.
It's actually quite bright and quite irritating, so I'm just going to stop the debugging session if you don't mind, because it's like sitting right next to me.
I think we're done with PyCam for now. I think we can say goodbye to PyCam, which is good. So I think now we should just quickly jump back to the slides to do a little quick recap. And if we just jump onto the next slide, then so this is essentially a little bit of a recap of the different sort of scenarios and options you've got for doing remote development with CLion there. So they target different scenarios, and they are for different things, and they give you different sort of capabilities. So if you're doing Gateway, you can then target everything being remotely. So the source lives remotely, the language processing, the IDE itself runs remotely, compiling and run and debug, everything happens remotely. You can work with local sources, like we saw at the start of Timur's demo there, and the source and the language processing all live locally. So you're running a local instance of CLion with your local copy of the code, but things get pushed up to the remote machine there. The compiling happens on the remote machine, the running and the debugging happen on the remote machine. The same with WSL and Docker, although those, the remote machine in that instance there might actually be running locally, bizarrely. And then, of course, we've got remote debugging, which is like what we've got with the Raspberry Pi there, where we actually want to do the same. The source and the language processing is all local, but the compiling is local too. We're going to cross-compile and then upload the executable to the remote machine and run and debug that on the remote machine. And then finally, we've got Code with Me. Code with Me is the host is running locally. I can be running any of those scenarios, but then I can come along as a guest, and it's all remote. From my point of view, as a guest, the source is remote, the language processing is remote, the compiling is remote, it's happening on Timur's machine, as is the running and debugging. So we could mix that all up there as well. And finally, with Code with Me, you've got collaborative editing too.
So it seems like because Gateway and Code would be, they both use the same thin client, right? So
Yes.
is it fair to say that Gateway is essentially like Code with me with yourself, or what's the difference there?
Not exactly. They are targeted at different scenarios. It's the same team who has built the two there, and they're based on the same technology. The idea of kind of splitting apart the IDE into a language processing backend and a thin client user interface, but they serve different purposes. So Code with me is for collaborative editing. The IDE is running on your machine, and we connect to that and we work with it. It's a very different scenario. So, for example, I don't get, as a guest, I don't get access to all of the features of CLion. I get access to the features that make sense as a guest. So I get the editor, I can work with you collaboratively, I can see the project view, but I don't necessarily get the terminal. I don't get
it's all configurable, right, as we saw.
Yeah, but also I don't get things like project settings because I don't own the project. I don't need to work with project settings and things like that. So there's various features that are not necessary for a guest. Whereas when we're talking with Code with me, if you squint, it is kind of like, sorry, if we're talking remote development and Gateway, if you squint, there's a certain similarity there. We've got the IDE running as a backend on a remote machine and then our thin client, but everything has to work there. So you've got all of the features are working and it's single user as well. So it's me connecting to a machine and getting the normal CLion experience. And currently we do not have support for collaborative editing in remote development. It's something that's on the roadmap, and it's something that we will be coming to at some point. But right now, remote development with Gateway is single user.
Right. Yeah, that makes sense.
Now then, before we move on, I'm going to actually bring back my demos because I turned it off and back on again, and things are working again, obviously. So I just want to show you a couple of things with remote development which didn't quite work before. So, for example, if I just jump to my Gregorian calendar, things like find usages, I can just do the find usages and I get the usual user interface. Again, everything's running remotely. The language processing is running remotely there. All of this information is coming from the remote machine, and I can use this. Oops, wrong button.
It's actually really responsive now as well.
Yeah, it works great. So I'm not quite sure what was happening earlier, but we can see, it's updating the preview panel on the right there. In fact, once you're in the preview panel, you can do all sorts of things and control click and navigate around there. If I go back to my main.cpp and hit debug, I've got a breakpoint in there, and now, nope. Where are you? Oh no, I've got the wrong thing selected there. Sorry, calendar run and hit debug. Then I can put my year in, 2022, month of 7, date of 26, and there we go. I hit at a breakpoint. So again, I'm running everything remotely. I've got the full debugger experience, as you'd expect. I can hover over items and see they're being shown there. There's items being shown on the surface of the editor pane itself, and I can sort of step in there, and I can modify those values and run there too. And then finally, just quickly, is I've got my tests. You can see now it's picked up my tests with the gutter icons. I can click there, click run, and it will run through my tests and show me that I've got a bug there, which I can very quickly fix and run that. It'll build any second. Oh, it's going so well. Come on, you can do it. So there we go. It'll build, and we get green tests. So we're back there.
So when you were navigating in the IDE, it looked to me as if you were running like a local CLion.
Yes, so
it was very responsive.
That's the point. Is that you're supposed to be you feel you've got the same feature set as the local IDE. You should have the same look and feel. You should have the same experience as well. The editor is a local editor, although the files themselves are remote, and so you get you should get the best of both worlds basically.
Cool.
Okay, so I think, is it time for some questions? Do we have any questions that we'd like to talk about? Is Anastasia there?
Yeah, thank you very much, first of all, for your amazing presentations. I really enjoyed the blinking part and how you changed the frequency. Yeah, it worked nicely. So yeah, we had some questions on the go. I answered quite many of them, but I think we can reiterate at least on some. So, like, yeah, there were questions on the thin client part, so maybe you can check them out and address. So there was just one about the like, if I have bare Linux server with just access to internet and access to SSH, then I can connect by gateway, and the entire process of installing CLion can be done from gateway. Is it correct?
Yes, that's absolutely true. So Gateway is all about managing that whole thing for you. You give Gateway a plain old SSH server running Linux, and Gateway will connect to it. It will see what's installed already, if you've got any IDEs already installed. And if not, it will download it, it will launch it, and then it will connect to it within client. So Gateway does everything. That's that's the point of the name. It's a gateway between you running locally and running an IDE remotely. So yes, so that's the best way and simplest way of testing this out, is get a plain SSH server. It can be a remote machine. I've done it on my Mac here with Parallels. Remote machine, simple Ubuntu or whatever distribution there, SSH connect to it and give it a go.
Yeah, and I think there was some misunderstanding in the very beginning. I shared the link to the system requirements. Actually, Gateway could run on any platform.
Oh, yes.
Remote machine you're connecting to should be Linux. So the exact requirements are in the web help. So I shared the link. You can find it there. So just check it out.
Yeah,
if you have any questions about any specific Linux version or whatever.
Yeah, absolutely. That is. Sorry, I just wanted to just say then. Yeah, the Gateway can run on Mac, Windows, and Linux. I'm running it here on a Mac, but it's the same experience on Windows and Linux as well. But you need a Linux-based server right now.
Yeah, and there was a similar question regarding the code with me and like how you shared the invitation. So like Timur just shared the link to the thin client. So the question was if I need anything to join, or I just need to follow the link and it will download everything for me.
Yep, that's exactly it. Again, you just follow the link. It will download the client for you and automatically connect. And so it's very easy.
Yeah, the only thing we didn't show on the screen is like how I copy pasted the link and sent it to Matt. But
yeah, so that not everyone joins it.
Yeah.
I mean, the code with me can work. Code with me can work with up to 100 people, so we could get a whole lot of mob programming if people click that link.
Well, yeah, maybe not on my main development machine here, but yes.
Yeah, and there was also a question regarding the licensing in that case. So if I shared the link to the pricing, but maybe Matt, you can comment on how this works in general. So if what kind of licenses are needed here? So what is
this
included,
the licensing
maybe
for Gateway or for Code with Me?
For Code with Me part. For Code with Me.
Yes, so Code with Me is included with your subscription. So if you've already got a subscription, you can invite guests to join you, and that's absolutely fine. Then people can just join you, and there's no extra demands on your license. So it's all included with your current subscription.
So basically, the 100 people that you're inviting to your mob programming session, they don't need to have a license at all.
Correct. The guest does not need a license. You'll need a license for the host. We also support Code with Me for the community editions as well, but then the sessions are limited. I think the number of people joining is limited. I don't think you can have 100 friends join you with that one, but each session then is limited to 30 minutes, and then you have to sort of start again.
And there's a very I think useful question on privacy matters. So when using Gateway or Code with Me, maybe you can also address that, like how the data is exchanged between the thin client and the remote machine. Can I be sure that JetBrains can see what I do, or maybe can't?
Yeah, absolutely. We can't see anything. So all of the data is end-to-end encrypted. So if you are using Code with Me, for example, we try to do peer-to-peer when possible. So, if you've got two machines sitting next to each other, it should be peer-to-peer, and that'll be end-to-end encrypted, and we don't see anything. If you can't get through with peer-to-peer, we do have a relay server, so the data could come up to a JetBrains server and then back down to you, but that is encrypted, and we don't see any of it. We can't unencrypt it. We don't have the information to unencrypt it at all. Similar with remote development, it's slightly different. Gateway has a different system of working. We don't have the relay server there at all. You make an SSH connection to that machine, and we use SSH tunneling to talk to the IDE backend there. And again, so that's all running over SSH.
Cool, thanks. There was one more question regarding the thin client and gateway, like if it works for two people accessing the same machine and same source code.
Unfortunately, not yet. So we would like to get Gateway working with Code with Me, but right now it only works with sort of a single user, as a way of putting it. So there is no collaborative editing with Gateway right now. It's on the roadmap and it's something we'd like to address, but right now you can only have one person using the source at the time.
Okay, thank you. And also regarding the gateway, like, is it possible to download and install the thin client or the remote CLion client manually, such that like IT people can install it for me, for the team?
Yes, for the IDE backend. It's more complicated for the thin client. So the thin client has to be the same version as the IDE itself, and also Gateway needs to manage the connection between the two. So you still need Gateway, and Gateway is in control of downloading the thin client. But when we connect to a server to the remote machine, we look to see what IDEs are installed and start that. And so it's absolutely possible for IT department to give you a server which has got the IDE backend pre-installed. And in fact, that's essentially what JetBrains Space and Gitpod do for their sort of orchestration systems. So, excuse me, the JetBrains Space and Gitpod provide a sort of an orchestration for building an environment that you can use. And part of that is installing the IDE backend. In fact, they take a little bit further and they run the IDE backend first to warm things up. And so it can actually load the project, run through indexing, close it down and snapshot it, so that when you pick up one of these built environments, you don't have to do any indexing. You just get up and start running. And that's great for new team members getting up to speed quickly. Just grab a new environment and start going without any extra wait for compiling or indexing. And it's great for switching branches as well. If you need a new branch, just point it at a different environment. So yes, you can definitely pre-install the backend.
Okay, and maybe the last two questions before we wrap up. One is about, again, the gateway. So any technique to improve IDE responsiveness with large projects that seem to index too many files? I've been using Gateway and sometimes the autofill and find features can be sluggish. So any advice here, Matt?
The best thing to do is to give your machine the resources it needs. So if it's a virtual machine, is to make sure that you've got a virtual machine which is the right kind of size to deal with this kind of a project. And again, similarly with the disks and the resources you've got going there, it's very similar to the requirements for improving performance when running locally. So make sure that you've got the power in your machine to do that. But then on top of that, you want to make sure that your network connectivity is also good. So for example, my machine is connected to EC2 in AWS, which means that I've got a good, powerful machine and also known good networking connectivity. And that can help a lot.
Okay, thank you. And maybe the last question that I'll try to address myself is about the Docker. So there were a few questions on the go regarding like if you can connect to the remote container, or if I can point CLion to a specific path in the container where the sources are. So actually the Docker toolchain is kind of a simplified workflow, which we do support in CLion to work with the Docker image, and it works the way we described. Like it starts the container, it mounts the source folder, and then you can work with it. For anything else, we do recommend to use the remote mode. So if that's the remote container, simply treat it as a remote machine and work with it that way. So it will work nicely. And also, if you have sources already, like in the container, you have some dedicated path, also do the remote flows. Don't use the this simplified Docker toolchain, which is for maybe more lightweight setup. So, but it works nicely for that setup. If you have something more complicated, so just do refer to the remote mode.
Yeah.
And
so I actually
forgot
forgot to say that. I think I said that CLion under the hood kind of mounts the project into the kind of container file system. What I didn't say is that in order to then invoke the compiler and like that kind of stuff, it just runs like Docker run, whatever, the usual like way you can run any command on a Docker container. So it's just doing that basically under the hood, as far as I understand. So with the remote Docker setup, that's not going to work, as Anastasia said. So then you will have to set up SSH on the Docker container, which actually is easy to do. This was the way to do it before we had the custom Docker toolchain, and I think we had a video on that as well. So that's actually not that difficult. It works the same as with any remote machine with local sources.
Mm-hmm. Yeah, that's correct. And the video is available as well on our YouTube channel, and it's dedicated to the Docker toolchain. Okay, let's wrap up here. So we have a few useful links. So I shared them during the session. You can also find them here on the slides. So you can try CLion. There is a free 30-day trial on our site. There is also a very useful article dedicated to all the ways of remote development with CLion in our web help. And also you can consult the remote development web page, which is general for all our IntelliJ tools. So you can follow us on Twitter, and there is a link to the YouTube channel where all the videos we actually mentioned here are available. So thank you for joining, and follow us for more webinars. And thank you, and bye.
Thank you very much. Bye.
Excellent.
Thank you for listening.
Bye-bye.